let's revisit why sampling distributions are important in statistics. Now, in statistics, we're often trying to answer questions regarding the population, but we can only observe the samples that we collect and make inference on the population parameters that we are interested in. So, for example, we are interested in the population mean, right? This could be the average height, average income, right? And so on. Right? So, what do we do? So, first step, right, we choose X bar as estimator for mu. Okay, this is not the only estimator for mu. There's plenty of estimators for mu. And just a reminder, X bar is equals summation xi over n. Right. This tells you what to do with our sample data. Right? If you have a sample data x1 through xn, X bar is a set of instructions tell you how to construct the estimator. Right? Now, why do we choose X bar? Well, we choose X bar because we know its sampling distribution. Right? We know that X bar, as long as the sample is random, X bar, right, will have a normal distribution, right? Why? Because if n is greater than or equal to 30, right, it will have a normal distribution. Right? This is the sampling distribution of X bar. We know that X bar centers at mu. Why? Because it is unbiased. Furthermore, we know that X bar has a standard error of sigma over root n, right? And with this, we can conduct hypothesis tests, we can do interval estimation, right? And we can use this information to make inference about, right? To make inference about mu, right? Now, so to make inference about mu. Okay. Now, another population parameter that we like to make inference on is the population variance, right? And often this is actually more interesting than just the mean, right? Things like income inequality, stock prices, like train arrival time. Right? We want, so for example, right, train arrival time, right? What we care a lot is, is the train on time, right? Is there going to be a lot of variance between the train arrival times, right, or income inequality? So then to do the same, to do this, we will need the sampling distribution of the sample variance, right? Why the sample variance? Because, right, the S2 is the estimator for sigma square. Right? Now, why is S squared the estimator? Well, because S squared is unbiased. Right? What that means is the expected value of S squared equals sigma squared. Okay? All right. We didn't prove this. Right? If you go into a higher level statistics class, this is what you will prove mathematically, but we don't have to do that. We can take this as given. All right. Now, we like to use S squared as an estimator, but then to make interval estimations or to make hypothesis tests, we will need to know the sampling distribution, meaning that we know that S squared, right? We know that S squared centers at sigma squared, right? But what we're interested in is, like, for example, what is the distribution? Is it normal? Or is it uniform, right? Or is it any kind of other shape, right? Furthermore, what we like to know is the standard error of S squared, right? This kind of sounds a little bit weird, right? The standard deviation of the variance, or this, right? What is this equal to? Okay. Now, unfortunately, S squared, we cannot use the central limit theorem. So the central limit theorem does not apply. That means right, it is not S squared. It is not normally distributed, right? Okay, so this is what we've been relying on, right, for the whole semester to conduct our test. So if this F squared is not normally distributed, then what can we do, right? How can we how can we answer questions, like this? Like, for example, like this one, I have a population. So if I know the population variance, right, is 144, we collect the sample of 51 people, and then we found the sample. Right, we found the sample variance to be 185. What is the probability? What that is saying is, what is the probability, right, that S squared, right, S squared is greater than or equal to 185, given that sigma squared equals 144 and my sample size equals to 51, right? I would like to be able to answer this question, and I can't answer this question until I know the distribution. Okay, so okay, but don't but there is a way, right? We can find some workaround even though the central limit theorem doesn't work.